Crash Course Instrumentation, Episode 44. Troubleshooting with a multimeter. Real-world techniques. Taking a measurement is one thing. Knowing what to do with it? That's where the pros shine. In this episode of Crash Course Instrumentation, we're putting the multimeter to work. We'll cover real-world troubleshooting strategies and show how voltage, current, and resistance readings can lead you straight to the root of a problem. Think like a troubleshooter. Always start with a question. Are we missing power? Is the circuit open? Is a load drawing too much or too little current? Multimeters don't fix problems. They reveal clues. It's your job to ask smart questions, then use the meter to get clear answers. Start simple. Is voltage present where it should be? Is there continuity where there should be a connection? Is current flowing where and when it's expected? Use voltage to check for opens, drops, and power supply problems. When something isn't working, the first question is often, is it getting power? Place your probes across the power terminals. If you expect 24 volts direct current and see 0, that tells you power isn't arriving. But here's the key. A device can show full voltage at the input and still not operate if the ground path is open or if there's a voltage drop upstream. Example. If you measure 24 volts across a relay coil, but it won't pull in, try measuring from each terminal to ground. If one terminal shows 24 volts and the other shows 23.5, that half-volt drop might mean a loose wire or high-resistance connection. Use point-to-point voltage testing to follow the flow. Compare expected voltages to actual voltages. Wherever it changes, that's your suspect area. Use continuity and resistance to test fuses, jumpers, and wiring integrity. Power down the circuit and switch to continuity mode. Touch the leads across fuses, jumpers, or terminal strips. You should hear a beep or see very low resistance. If not, the path is open. Always test your leads first by touching them together. That verifies your meter is working. Also remember, continuity only tells you if a connection exists, not whether it's good. A corroded wire might still beep, but its resistance under load could be too high. If in doubt, measure resistance instead. Remove the wire or component from the circuit if needed to get an accurate reading. Use current to check loads and confirm circuit behavior. If a motor or solenoid isn't acting right, current measurement can tell you if it's being energized. Use a clamp meter whenever possible. It's safer and avoids opening the circuit. For low-current analog signals, you may need to break the loop and insert your digital multimeter in series. Be methodical. Turn off power, use the correct jack, and restore connections carefully. Compare readings to expected values. Too much current can mean a short or failed load. Too little can indicate an open or weak connection. Document everything. Keep a troubleshooting log. Write down what you measured, where you measured it, what you expected to see, what you actually saw. This not only helps you think clearly, but also gives the next tech a roadmap if the problem recurs. Did you know? In 1995, a major failure occurred at the Washington Metro subway system due to a single loose wire terminal. Operators were getting voltage readings at the control panel, but the train detection signal was not reaching the track circuit. After hours of testing, the problem was traced to a voltage drop across a corroded ground splice. The meter read full voltage across the terminals, but not relative to system ground. A voltage drop of just 1.8 volts caused a critical logic controller to fail to trigger. This failure led to delays, emergency manual operation, and an eventual change in test procedures, emphasizing reference to ground voltage testing, and not just terminal to terminal. Quick recap. Use your meter to answer specific questions. Is there voltage? Is there continuity? Is current flowing? A voltage drop testing reveals loose connections. Continuity is quick, but resistance gives deeper answers. Clamp meters are ideal for current checks. Document everything. Observations lead to answers. Thanks for watching episode 44 of Crash Course Instrumentation. Next time, we'll wrap up this series with some advanced test scenarios and review everything we've learned so far. Special thanks to Tony Kuphaldt and the open source ModL community. Explore more at ibiblio.org/Kuphaldi/Socratic/model/ like, subscribe, and join our Facebook group to keep learning and sharpening your skills.